Welcome to the class, my dear students. In today's lecture, I am going to explain you about infinite series. In my previous lecture, I have explained you about the infinite sequence and what do you mean by the limit of a sequence. So now what is meant by the infinite series means, let us take first an infinite sequence where n is equal to 1 to infinity. In this infinite sequence, if we write an expression, let us write down an expression. What is that expression? An expression of the form, the sum of these numbers, that means these terms, I say a1 plus a2 plus a3 and so on, plus an and so on. The sum of all the terms in this particular infinite sequence is called as an infinite series. Is called as an infinite series. Now, how to represent this? The representation, the notation for this infinite series is, the notation is sigma n is equal to 1 to infinity. So, this is what the notation for the infinite series. Now, let us see one example. We have already done this example in the previous lecture. That is 1 by 2, 1 by 4, 1 by 8, 1 by 16 and so on. So this is what the infinite sequence, and we have named it as 1 over 2 to the power of n minus 1, and n is starting from 1 to infinity. So this is the infinite sequence. Okay. Now I want the sum of the first two terms. Sum of the first two terms. Let us see what is this. This is given by 1 plus half. What is 1 plus half? Is 3 by 2. Okay. Now let us go to find out what is the sum of the first three terms. What is the first three terms now? Is 1 plus half plus 1 over 4. Correct? And what is 1 plus half? We have already got it, which is 3 by 2 plus 1 over 4. What is 3 by 2 plus 1 over 4? It is given by 6 plus 1, 7 over 4. Correct? 7 over 4. And then what is the, it is 7 over 4. Now what is the sum of, let us take the sum of first four terms. First four terms let us take. That is what is 1 plus half plus 1 over 4 plus 1 over 8, and that gives you 7 over 4 plus 1 over 8, and that gives you 15 over 8, right? Okay. So what is your observation here? When I go on taking all the terms like this, some of the first 5 terms, first 6 terms like that, suppose, what is some rule is hidden here, try to understand. So here when there is 2, the denominator is what? 1. I can say it is 1, right? So 2 half. And when it is 4, the denominator is here 2. And when it is 8, the denominator in the previous term is half of that, which is 4. And even if you write the first 5 terms, let us say, first 5 terms, so that you can generalize the things here. 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 over 16, let us say. And this gives you 15 over 8 plus 1 over 16. And that gives you 31 over 16. Okay. So now let me check with this now. When I am taking the first two terms, my second term is having 2. First term denominator is half of 2. My second term is 4. First term denominator is half of 4. Second term is 8. First term denominator is half of 8, which is 4. Here it is 16. Here it is 8. Is it clear? And let us go to next. The numerator here. The numerator is just 1 minus of this number. 1 minus of this denominator. Now look at this 4, and this is 1 minus of 4, which is 3. The denominator, I am talking about the numerator now. And if it is 8, then it is 1 minus, that means 7. If it is 16, it is 16 minus 1, that is 15. Why I am talking about all this is, if I want to find out the sum of an infinite number of numbers I want to take. So I am able to see that my x is in the denominator, let us say. What is its previous sum is x by 2, correct? And what is the numerator here is x minus 1. It is sum of some infinite number of terms, let us say, whatever it is, okay? Sum of infinite number of terms in the given sequence. Sum of infinite number. Some x I am getting. What is that x? Before that number is x by 2 and is a denominator, and the numerator is 1 minus of this x. Are you able to understand? For your understanding, if I write 6 terms, let us say, some of the first 6 terms also, what is happening here? It is 1 plus 1 by 2, 1 by 16 plus 1 by 32. So what it is? 31 by 16 plus the next number is 32. Is it happening? Try to understand. My x is here. X half is the previous denominator and 1 minus of this x is your this now. I hope you are able to convince with this particular relation as I am generalizing the thing here. Now let us see the calculation here. X minus 1, and when I flip the fraction, because there is a denominator where you have a fraction, 2 by x and plus 1 over x. Okay. So what is this giving you? 2x minus 2 over x plus 1 over x. Okay. What is this giving you again? 2x over x, which is 2, minus 2 over x plus 1 over x. So what is this value gives you? 2 minus 1 over x. So what do you mean by 2 minus 1 over x? You can understand one thing, that whatever the sum of the infinite terms you are having, as my x is going to infinity, as my x goes to infinity, definitely 1 by infinity is less than 1 only, right? You put x is 100, it is 0.001. You put x is 1000, it is 0.0001. Like that, if you get whatever 1 by, as x is going to infinity, my 1 by x is definitely less than 1. So the whole sum of the infinite terms is going to 2 minus 1 by x. Try to understand. So can we understand one important thing here, that whatever the infinite terms you are increasing, you are not going to cross 2. It is up to 2 minus 1 over very bigger number it is. It is, of course, whatever the bigger number you write. Let me put x is 1 x at least. 2 minus 1. When x is 1 by 2, the number 3 by 2 or whatever, x 1 by x doesn't cross. And 2 minus of that number means it cannot be 0. It cannot be 1. It cannot be, whatever you say, 2 is the threshold, you can say. Are you able to understand? So definitely 2 is the sum of the infinite numbers is going to 2, you can say. So what we can say about the next term about the limit of series. What do you mean by the limit of the series? As limit n is going to infinity, you can say that the sum of the numbers, that means a1 plus a2 plus an and so on, is also limit n tends to infinity, sigma n is equal to 1 to infinity, let us say, that will be equal to L. But when it happens for this, what we have done in the previous example, I will explain you now. When I write the sum of the first 2 terms, I call this as my first partial sum. First 2 terms means my second partial sum of the series. Second partial sum. What do you mean by second partial sum? Means the first 2 terms, S2, is given by 3 by 2. When I say the first 3 terms, that means this is the nth partial sum. That means the third partial sum of the series. That is given by S3. And that value we got it as 7 by 4. Next, my fourth partial sum. What is meant by the fourth partial sum of the series? And that is given by S4. And that value we got it as 15 by 8. And then fifth partial sum. What is meant by the fifth partial sum is given by S5, and the value of S5 is 31 by 16. So likewise, if I want to find out sum of the nth partial sum, okay, then it is giving you my this value. So what you can say about the limit now, when I cannot add all the numbers which are from 1 to infinity, right? So what we do now, make it as a convenient way we write down as the partial sum of the sequence. The partial sum, some sequence you can say, of the sequence you can say. So what is the partial sum of the sequence is given by Sn. The sequence is given by, denoted by Sn, and it is S1 means it is just the number A1. S2 means it is the first two terms, how we have done in the previous example. S3 is my first, second and third term sum. So it goes on like this. Okay. Now, what do you mean by Sn now? Sn is given by A1 plus A2 plus A3 and so on plus An, which is the nth partial sum of the series. How can I rewrite this? It is given by n is equal, let me write down that k is equal to 1 to n ak. K stands from 1 to n. My last term is n. That is the nth partial sum. Is the of the series is Sn. Is called as the nth partial sum. The nth partial sum of the series. Nth partial sum of the series sigma n is equal to 1 to infinity. So now this Sn is called as the nth partial sum. Now, as I told you about the sequence, my sequence 1, 1 by 2 and so on is the limit of that sequence if I say. Now, coming to this point now, what is meant by the limit of the or you can say the convergent or divergent series. The convergent series I write. What is meant by this? If my nth partial sum, if limit n tends to infinity, this Sn, the nth partial sum, limit is L suppose, and if this L is finite, if L is finite, then not only the nth partial sum, the total series Sn, n is equal to 1 to infinity is said to be convergent. So this is what you can say. This is what the easiest thing for us to understand, that when you write down the nth partial sum, suppose the nth partial sum of the series when you write, because it is difficult to find out all the nth up to infinite number of terms of the series like this suppose, but if we find out the nth partial sum of the series, and if we find out that there is a limit existing for that nth partial sum, we can say that even for the whole series also the limit exists, and we say that limit is finite suppose, then it is convergent. And if this L is infinite, then the series summation n is equal to 1 to infinity an is divergent, when the series is divergent, when this goes to infinity. I hope you could understand. The series is convergent when it happens to be, when the nth partial sum is finite, going the